thing before we get into the last two shortcuts to prove triangles congruent, let's just review here quickly and go through what we should already know. So, determine whether or not it's possible to prove the triangles are congruent. How do you know? So, you're just using our first three shortcuts, side angle, side, 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 and HL. Clearly on number one, I see those right angles and I'm thinking HL. Just as a reminder, your hypotenuse is the longest side across from the right angle. So I think we do have HL. And then the leg, of course, is just a side. So I'm going to say yes, HL. And if you remember, there were some of these on your quiz yesterday. Man, a lot of you, there were a lot of perfect pages. Okay, what do you think about two? Yes or no? I see one no, some yeses. So let's not forget, of course, geometry is the gift that keeps on giving. Don't forget about your old school angles there in the middle. Why are those angles congruent? What type of angles are they? Vertical, I hear it from the back. So we do have some congruent triangles. Let me put a yes here. Which one of our first three shortcuts is it? So yeah, side angle, side. I like it. Okay, let me flip the slide because of course I have the next two. I can't fit all these triangles on the same page. So right away I was thinking, ooh, right angles, hypotenuse leg. Does hypotenuse leg work on this one? Anybody? Remember, your hypotenuse is across from the right angle. Do you know that that's congruent? So I'm not ready to say a no yet. I'm ready to say no for hypotenuse leg, but I'm thinking it could be one of our other ones. So let me just quickly erase this. So my next question for you, if this is a right angle, is the angle right next to it also right? Because they have to total to 180, 90 plus 90 is 180, makes that linear pair. So we do have congruent angles. I do have a side. Let's not forget our congruent shared side. So now I'm thinking, oh yeah, they're congruent. Which shortcut? Say yes again, side angle, side. All right, let's look at the fourth one. Now, I don't love the picture. Like, I think it's just hard to display it on here. These are supposed to be, let's do them in red, those little triangles. Not the world's best triangles. What do the triangles mean? What type of lines? Triangles indicate what type of lines? We're lively today. Parallel lines. So right away, of course, I'm thinking about my alternate interior, alternate exterior, corresponding, all of that fun-filled stuff. Also, of course, we have our vertical angles. I'm going to mark those. Those are the obvious ones. Now, alternate interior. We do have some of these. This one, I'm going to put two on it. There's alternate interior. Now, there's another set of alternate interior too, but part of me, I'm questioning right now why I'm even bothering. Because is AAA one of our shortcuts? No, AAA isn't a thing, people, so not possible. I'm just going to put no for that one. Any questions on that one? That's the tricky one. We have side, 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 but not AAA. Okay, so like I said, I'm going to show you the last two shortcuts today. So we're going to do angle, side, angle, which just to give you a preview, I kind of drew the pictures up here on the board. Notice the S, the side, is in between the two angles. So of course use the abbreviation to help you. ASA, the side's in between the angles. And then we're going to do angle, angle, side, where the side is not in between the angles. It is not the included side. So, a few things you got to fill in on the blanks here. If two angles in the included side of one triangle, so I think the first blank you got to fill in is angles, and then included are congruent to two angles in the included side of a second triangle, then the two triangles are congruent. So remember, included is that fancy word for in between. We've seen included earlier, side, angle, side, the angles in between the sides. Now, of course, you have angle, side, angle. The side is in between the angles. So again, don't get caught up on, oh, is it included? Try to use the abbreviation, ASA, to help you. The S has to be in the middle. All right, our last and final shortcut, angle, angle, side. If two angles, two A's, and the non-included side, we'll talk about that here in the picture, are congruent to two angles and the corresponding non-included side, then the triangles are congruent. So again, try to use the abbreviation, the AAS, to help you, because you have angle, angle, side. If we had the congruent side in between, it'd be ASA. So just take a look at what you have. I always work in order, single, double, and we got the side there. So those are the two shortcuts we're going to add to it. Now, it's a free-for-all, people. All 5 are in play from here on out. So when you flip the page on your notes and you see a wonderful sheet of 9 pictures of triangles, it's a free-for-all. So I just put this is on the top of the note page just so it's in front of you. Any and all of them apply to these pictures. Okay, here we go, let's do it. Now, my pro tip is always, before I'm like, oh gosh, what is it? I try to mark anything else congruent on the picture that's not specifically marked, like this shared side, like this shared side, like this shared side. And I know there's more triangles, I just gotta scroll it down when I get to it. So let's take a look at our 2 triangles. I just start with 1, and I just start labeling with the single congruency. So I have an angle, angle, side. I'm just going to double check. I'm pretty sure it's angle, angle, side, but let's double check it works on the second triangle. Single, double, and then our side. So yep, I like it. Angle, angle, side. Shared side here, I better mark that guy. So again, I'm going to start with the single angle, angle, side, angle. So this time the side is what we call that included side. It's in between the 2 angles. Bless you. And that does work on the second triangle, angle, side, angle. Let's take a look at number 3. Now I see the right angle. Man, as soon as I see right angle, I want to think HL, okay? But remember, your hypotenuse is across from it. There's nothing marked on that, so I'm not thinking about HL. But of course, we do know right angles are congruent. Here's a hint for some upcoming proofs. Remember, right angle congruency theorem, RACT. RACT is coming back today. So I've got angle, a side, and an angle. Same thing over here. I got my right angle, my side in the middle, and then the other angle. You got it. Let me just scroll it up just a touch so we can see that bottom right angle there on 4 is just a little off the screen. All right, you guys are up. What do you think 4 is? What do we got? I hear mumblings. Hypotenuse leg. I hear you saying it because this time you do have that side across the right angle, the hypotenuse, and the leg. So remember, once we cover something in here, geometry is the gift that keeps on giving. It is a free-for-all. It is back in play. Okay, right angle. So I'm thinking hypotenuse leg, but I'm like, wait a minute, I only have hypotenuse. I don't have a leg, so that is out. So let's see if it's any of our other shortcuts. So angle, we've got an angle. So it is one of our new shortcuts. Which one is it? You tell me. Is it angle, angle, side, or angle, side, angle? Purple or red on the board? What do you got? Angle.
Angle, side.
Got it. I love this stuff. We could do it all day. What do you think about 6? 6 is, I'm kind of like, wait a minute. Don't we need 3 pieces of congruency unless it's HL and there's a right angle? There's no right angle in it, so HL is clearly out. And we would need 3 pieces of congruency. So that is a big fat no. I'm not sure what's going out in the hall, but it scares me a little bit. Okay, let's look at 7. Aye. Okay, so carrying on. Now again, let's mark our congruent pieces here. We've got our vertical angles. We got our shared side. We have another set of vertical angles. See what we can figure out. What do you think for 7? It's an old one. What do you got for 7? I hear it, side angle, side. You got it. I like 8. Nobody gets 8 wrong. What's 8? Side, side, side. It's like a foreign language in here. All right, what do you think about 9? Which one is 9? Let me get out of the way. It's either purple or red. I hear you. I hear purple. Angle side is correct because the side is not in between. All right, with no further ado, what's left? The proofs. Of course. Of course. Love the proofs. Let's do the proofs. Let's see what we can do. Elliot. I'm going to wait till I get a minute to write you a pass, but yes. All right, angle ABC is congruent. Now I'm looking over there at the picture, and they didn't mark anything on the picture for us, so we're going to have to mark the picture. So angle, careful here, ABC, so this one is congruent to DCB. Got it? Okay, clearly there is more in the given. Let's keep writing that, because I see they didn't mark anything. Just not nice. So I'm going to mark this one also. So ACB, this guy, is congruent to DBC. Got it. And let's write given, of course. Now, my other pro tip, of course, well, two pro tips. One, just like I was doing on the last, all those triangles, mark any other pieces of congruency, like this shared side. So I'm going to mark that. Then, before I start working on my proof, I figure out which of the shortcuts is it. Is it side, 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 angle, side, HL? What is it to prove those two triangles are congruent? Which shortcut? Angle, one of the bottom two. Angle, side, angle. So one thing I noticed, like when you guys were writing the proofs on your quiz, which there was some really good proof writing, like people would mark like that purple side, but they didn't put it in the proof. You've got to put it in the proof. I need 3 pieces of congruency in here. You only have 2 right now. I do need the third one. I need that shared side. So I'm going to say segment BC is congruent. And that's the easiest statement out there. What's your reason? Starts with an R. Reflexive. All right, take a look. Do you have 3 congruent statements in the proof? Yes, no? We have 3, right? The green, the red, the purple. So we've got everything. 3-step proof. We're ready for the final line, my friends. Oh, that's 2, sorry. 3. Triangle ABC is congruent. And of course our reason, angle, side, angle. I like a 3-step proof. Yeah. Any questions on that guy? That's it. We left you too much room for this one. That's all it took. All right, 1 down, 2 to go. C's, oh, they didn't mark anything either. Let's mark as we go here. Angle C is congruent to E. So let's mark that. Yeah, got it. And then it says segment CG, perpendicular. All right, we're going to need this. What do perpendicular lines make? Yeah, so I'm going to mark that on here. So CG, GF, there's a right angle. Okay, man, there's a lot in the given here. EF, perpendicular to FG. So EF, the side one, perpendicular to FG. Got it. And last but not least, D is the midpoint. I can't put it all in one line. D is the midpoint. I swear every day when we write these, midpoint comes up. For the millionth time, I'll ask again, what does the midpoint do? Cuts it in half, cuts it in the middle. So D is the midpoint of GF, so I know those guys are congruent. Now, before I get into writing out all the steps of the proof, which shortcut is going to prove those triangles are congruent? Right angle, I'm thinking HL, then I'm like, nope, no I'm not, no I'm not, because you don't have your hypotenuse across the right angle. So that guy's out. It's clearly not side, side, side. So you got 3 choices left. What's it going to be? Angle, angle, side. I hear it. So I know that's going to be my final reason. I just got to get to it. Now, we only have 1 piece of congruency in here. We need 2 more, my friends, 2 more. I'm going to do the easy one, the purple marks. I put those on because of the midpoint. So I'm going to put segment GD is congruent to segment DF. And I put that on because of midpoint. So definition of midpoint. All right, I got 2 pieces of congruency in here. I need the third. See it, Parker? So of course I put those right angles on there. Clearly we all know right angles are congruent. They're 90 degrees. We all know it. But I need to have that in my proof. Here's the thing. I can't just right now go straight to angle G is congruent to angle F because I have perpendicular. Perpendicular makes right angles, and right angles are congruent. So it's going to take me 2 steps to make this happen. That's a 3, a sloppy 3. I'm going to put angle G and angle F are right. Angles. Just put an angle symbol. And I put those right angle symbols on. I put those on, so I need that in my proof. And the reason I put those on is because you had perpendicular in the given, so definition of perpendicular. Now we know if they're right angles, we know they're congruent. Let's put that in. Angle G. Now, I threw it out there earlier as a reminder. We haven't used it a whole lot lately, but it has come up a couple times. What's your reason for the right angles being congruent? Starts with an R. Rect. I hear it. All right, take a look. Do I have 3 pieces of congruency over there on the left? I sure do. We're done. Let's put our final line in. And we already figured out from the beginning it was angle, angle, side. Triangle. Angle, angle, side. Got it. All right, one last proof to write for today. Well, for us to do today. There's a couple on the homework. Anna.
How many like households do you have to know? How do you know like how many things are supposed to be congruent?
So, because all of these except HL, all of them have 3 letters in them, so I know I need 3 pieces of congruency. However, I have to, whatever I gotta do to make it happen. So there's 1 piece, 2 piece, and then 3 pieces. HL, that's kind of ambiguous. HL, you really kind of need 3 things too. You need the hypotenuse and the leg, but you also need that lame statement in there somewhere that you have right triangles, because you can only use HL on right triangles. So I always kind of think 3. All right, C is, man, I didn't mark or do anything here. C is the midpoint of AD. Okay, right. I'm gonna abbreviate here. Given. Now, I'm going to go ahead and mark that. We know, I've asked a million times, you've said it a million times, it's in the middle, cuts it in half, C is the midpoint of AD. Got it. Also tells us angle A and angle D are right. So I'm going to put the right angle symbols on those. So as always, my pro tip, mark all pieces of congruency on the picture. There is something else you can mark on there. What is it? Vertical angles, I hear it. So I know I'm going to have backed at some point in here. My next question is, which shortcut are you using to prove those 2 triangles are congruent? Angle, side angle. Okay, so how many pieces of congruency do I have right now? 0. We have 0. There's not a congruent symbol anywhere on the left. So I need 3 pieces of congruency in here. So here's where we're going to make it happen. I'm going to start with the purple. That's the first thing I marked. I'm going to throw that in there. So AC, segment AC is congruent to segment CD. And I put that on because of the midpoint. So that's our definition of midpoint. Okay. Next thing I put on were the right angles. Now, they gave us that. They told us they were right angles. Clearly, we all know right angles are congruent. But I need to actually state that so I get to my 3 pieces as a congruency. We've already used it today. What's the reason for that? Rect. All right. We got 2 pieces of congruency. You need the third. What's the third? Backed. The blue vertical angles. This does seem like a foreign language today. Now, not a lot of us, but I just noticed on a couple of the quizzes, be careful how you name these angles. Nobody said angle C is congruent to C, so I'm like happy about that. But when you use the 3 letters, C is the vertex, so it has to be in the middle. So I'm gonna call it ACB. A line in here. Full screen it so I got more room. Because I feel like I'm at the bottom. And then I'm gonna call this one ECD. All right, check it. Do I have 3 pieces of congruency in there? I sure do. Write your proved line, angle, side angle, and we are done with it. Such a good proof. Angle, side, angle. Any questions on that one? There are 2 proofs on the homework. It's not that bad, it's not that bad. And like I said, next week we'll have a quiz. There's 4 proofs on it, 3 on the test.